As Ahmed said, I have been working with ASRY and few other companies as well. So my background is I'm a mechanical engineer and I'm an offshore engineer and a marine engineer as well. And I'm still in process of doing my master's from Australia on marine engineering. So apart from this, I count myself and my credibility is only on the base of experience, what I gathered from different shipyards and from different kind of projects. So to make today's session more interesting, I'm not keeping it more on the technical terms or the technical formulas, chemical formulas. I am taking more of a practical approach because this is what will be needed by you guys or anyone to work in the industry, any kind of industry, not just the marine sector. To work in an industry, you will need to have a practical approach on the problem solving and on daily day-to-day activities. Okay, so that's about me, and there's a general introduction about what I'm going to share today. So let me share my screen, the presentation on BWTS and EGCS, which is scrubber system. Give me a moment, I will share the screen now. Everyone can see my screen. Can you please anyone speak up and say whether my screen is visible to all of you?
Yes, we can see it.
Okay, thank you. Okay, so today there are two topics which we'll be talking about. One is the ballast water system management. Okay, so this is a mandatory from IMO for all kind of vessels which is traveling from one seas to another or from one part of the world to another part of the world, or if you are taking any kind of ballast from one waters to other waters, so that you don't disturb the marine life in the destination ports or destination locations during the deballasting. So on this, I will start with the understanding the BWTS process or the different types of BWTS that is available. So most of the BWTS, you have two different steps, okay, which is, as I said, I'm not going through the book, I'm going through the experience and more on the practical approach. So most of the BWTS that we have seen, you, for sure, you have physical separation. Okay, physical separation, you have surface filtration. I have seen 90% it is surface filtration and very few is hydrocyclone. Okay, this is 1 in a million or 1 in hundreds, you can say. Means these kind of hydrocyclones, we have not come across many BWTS system, and this is not easy to manage. So most of the owners or most of the designers go for surface filtration. And in some cases, it is added with a chemical enhancement, which is coagulation or flocculation, where you add a chemical and then you create the bubbles, micro bubbles, and the dirt or planktons more than 50 microns will come to the surface. Okay, and then you separate it. So most of the system you will have physical separation first, which is the first stage. And the second stage is the disinfection itself for much smaller particles, which is less than 50 microns. Okay, so for those kind of disinfection, we mostly see chlorination, electrolysis, or ozonization. Okay, these are the most common, which has been used by most of the vessels or most of the barges. Okay, and then again on the physical treatment, there is one more type, is the UV type. Okay, so this is the most common also for a smaller vessels around 150 to 200 meters or 250 meters, small vessels comparatively than a VLCC. Okay. Okay, the type of BWTS that ASRY has installed, or if I can say most of the shipyards has installed, you will find mostly these are the four different types of systems. Okay, and as I'm saying on the right side, most BWTS package are combinations of physical and one of these three types. So as I said, the first step is mostly the physical filtration. Okay, and the second step is either electrolysis or UV or chemical dosing. This is the most common and the most easiest to be installed on board a vessel. Okay, the BWTS that we installed on a diverse vessels are including oil tankers, bulkers, container vessels, car carriers, chemical tankers, crane barges, LNG vessels, platform support vessels, LPG, and anchor handling tugs. As I'm saying, most of the vessels which are from one part of the world to other part, if they are not in their local waters, they have to do this BWTS system. Okay, and the trades, what has to be done by the trades on the BWTS installation is the steelworks, electrical, piping, machinery, and engineering. Okay, so on the steelworks, you can see the major works that is being done is fabrication and installation of deck house. Like some of the systems where you have chemical dosing, you may be need to install a separate deck house or a separate cabin on board to fit with these equipments where all these equipments are mounted, because you may not have enough space in your engine room, or sometimes you may need to install acid tanks, so which is more suitable to install on the deck. Okay, then we have fabrication and installation of equipment foundation and the required structural modification. Okay, for electrical works, we have cable layings and termination. Then we have the sensors and pressure transmitters, temperature sensors, all these installation and pre-commissioning and loop checks. So most of the pre-commissioning and loop check is done by the shipyard. The final commissioning is done by the owner arranged contractor, or in case if the system was designed by shipyard, so shipyard takes the commissioning as well. Okay, and then for the piping works, we have fabrication of all different kind of pipings, GRE, GRP piping. Some systems where you have chemical injection, you need to have GRE or GRP piping. Okay, and then you have a lot of tubing works for valves for hydraulic or pneumatic. Okay, then you have machinery where we have the installation of the equipments. And as I said, in some cases where the shipyard takes the whole job, we do the 3D scanning before one of our 3D team or engineering team will go on board the vessel, and we do a 3D scanning and the feasibility check. And we prepare the detailed fabrication drawing, both for steel and piping, and as well as electrical. So in this case, it will be more like a turnkey project. Okay, this is a general schedule that I'm showing. This is not mandatory to be followed for all kind of BWTS system. So this is like one of the biggest system that we do for VLCCs and with chemical injection. So in my experience, what I have seen is UV system is one of the easiest because you have comparatively less equipments to be installed. You just have to install some pumps and UV bulbs and very minor piping modifications. So UV system is one of the easiest and the fastest to be done. But yes, UV is expensive. And then I can say that chemical injection is the one where you have the maximum equipments and maximum piping modifications and new pipings to be done. We have even done for some VLCCs, like you will have around 700 to 800 pipe spools to be fabricated and installed, which is quite a lot for BWTS one system. So in that case, you will see we start the procurement 60 days ahead in those kind of big projects, and then we take a minus 30, 1 month of prefabrication for all the pipes, all the foundations, and any cable trays or any kind of electrical panel foundation. And then you have day 0, and then we have 7 days of foundation installation, both for electrical and for mechanical equipments. Then from day 7 to day 12, we focus on the equipment installation. And then parallelly, we start with the piping and electrical works as well. And you see last 3 days, we keep it for pre-commissioning. This is what I'm talking about. This is pre-commissioning plus commissioning. So this is for one of the most biggest projects that I am showing. So this is not a hard, fast or thumb rule that every BWTS requires 25 days. Some requires less, some can even have more. Depends on the complexity of the project or the piping system, especially the piping. Okay, why I'm saying the complexity of the piping, because this is the next part. What I will talk about is the 3D scan for clash checks. Okay, this is what the designers do in the beginning when they do a 3D scanning to check the feasibility of any kind of system, both for BWTS and for scrubbers. They check, okay, where is the available spaces to install the equipments and what will be the piping routing. So what they try to do is with that 3D scanning, they try to avoid clashes with existing structural members. This is what is being focused by the designers and the 3D scanning. And then to avoid the clashes with existing piping or the existing systems. Then to plan the equipment arrangement. So where are these BWTS new equipments to be installed? That is also being decided by 3D scanning. Okay, the most suitable, most accessible, and in case of maintenance. So this all has to be taken into consideration. Okay, then to plan the electrical panels arrangement, to check the and plan the cable routing. So the cable routing, what you will have from the engine room, from different BWTS equipments. In case of VLCC, you will have it to the pump room and all the way to the bridge. Then the CCR, cargo control room. Okay, and just to highlight few clashes. So this is what the 3D designers or the 3D checks is being done. Okay, you will see an example. So these are the new pipes and there are some old structures or old pumps or old platforms which will clash here and there everywhere. So you can just see booster pump suction line. This is a new booster pump suction line clash with existing stair handrail and in way of stair passageway. So this is what I'm talking about. So these all will be done by the 3D scanning and then it's with the shipyard and with the owner to see the most easiest and the most fastest way that which modification suits the purpose. So we go for the easiest, which requires less modification and more safer to access to these pipings or the valves or the pumps. So these are few of the examples. Okay, so this is again one more example, booster pump suction header clash with existing brackets. So this is what I was talking about. We try to avoid any kind of structural clashes. So in this case also, again, it's always the shipyard and the owners make the final call about the rerouting or the easiest way possible. Again, freshwater lines and ODU. ODU is an oxidant dosing unit. This is one of the chemical injection treatment system. Clashing with existing stiffeners. Okay, then the next one is the electrolyzer and degasser units. These are all different kind of equipments that we have to install for BWTS. And it's new pipe clashing with existing storage racks. So this is also one concern, like when the designers design where the equipment has to be installed. So there is a lot of time when on the vessel, a lot of things, old storage or stores or some equipment has to be removed. Okay, in this case, you will see a ventilation duct clashing with existing stiffener. Okay, again, one more example of ODU discharge line clashing with the stiffeners. So this is the main thing that the 3D designers do. They scan it and they pass it to the owner and the shipyard, and then we look for the easiest option. Then the clash check, still we have discharge line clashing with existing piping. This is one of the most tedious or the most critical one that we see on board the vessel. Clashes with the stiffness can be avoided. You just have to reroute the new piping, but the most common or the most critical issues that we have is the pipes, new pipes clashing with the old pipes. So this is where it gets complicated because there are some systems which will be still in running conditions, or there are some systems which we are not able to modify. In both cases, this is where the class comes into picture also, because both the piping has been approved by class. And once we submit the drawing or owner submit the drawing, it takes quite some time for reapprovals and all. So this is what we see most critical, or one of the hiccups that we see on the projects, deciding which pipe to modify. Again, some more clash checks and some more obstructions or clashes. Okay, the AFU, these are the filters. These are the two big filters in white, which I'm talking about. These are the physical separation. So their pipes will be clashing with the longe stiffness. So again, in this case, these pipes are not easy to modify because most of the cases, these pipes are prefabricated. And in some rare cases, these pipings will have special kind of coating, example, rubber coating or glass flake. So in those cases, we try not to modify the piping and to modify the stiffness or give additional strengthening in line with the class requirements. Okay, again, few more examples of piping clashing with the brackets, the equipment clashing with the brackets or the structural members. Okay, so this is what I had to talk about the clashes. As I said, we are looking into more practical approach than on the theoretical or book definitions. So on board, when we are installing these equipments, these are the different kind of issues that we face day to day, and this is what decides the schedule. Okay, then these are the different kind of BWTS installations that we have done. This is not the complete system. This is just one of the few equipments. So every maker has their own system. We have Vatsila, we have Irma First, Alpha Level, EcoChlor, Sunrui. In this case, I can say like Irma First is the electrolysis system. So the two blue chambers, what we are seeing is the electrolysis cells. Okay, the Alpha Level on the left bottom is a UV system, the ultraviolet. Then the EcoChlor and the Sunrui on the right is chemical injection. Okay, then we have Panesia, TechCross, Headway, and a few other systems. We have done quite a few. I'm not showing all the systems. This is the most common systems what owners go for, or which is easily available in the market. Okay, on the BWTS, mostly I have covered everything on the practical side. Do anyone have a question or anything you want to put up your ideas or anything you want to ask me? I believe it's clear. And anyway, if anytime anything you want to ask, sorry, yeah, yes, go ahead.
Thank you very much for this amazing presentation. You have great knowledge. I'm sorry, I had meeting, so I couldn't attend in the start. But I would like to ask the process of the 3D scanning, why it is not
Yes.
done before making the 3D model of the piping.
Okay, to answer this question, yes, your question is very right, and maybe I missed this point. The 3D scanning is done couple of months before the fabrication is started, or even before in some cases when the owner purchased the equipment. So the 3D scanning is the first step when a owner decides to install a EGCS scrubber system or BWTS. So that is the first process where owner will invite or arrange some kind of third party or the shipyard to do a 3D scanning. And this is where I said we do a feasibility check. So what we or the 3D scanners will look for is the easiest way for pipe routing, for the equipment arrangement, and for the cable laying, for cable routing. So these are the three areas that 3D scanners will focus. And this is, yes, it is done few months in advance. So based on this only, we have a discussion with the owners that which pipe is to be modified, okay, or the stiffness to be modified. And based on that only the modification works is being done. And based on that only the final drawing is being prepared. But even after having so much of discussion or 3D scanning, I have seen most of the cases, end of the day, we still have some of the clashes on site. This could be one of the reason. What I have seen is most of the owners, to save money or to save time, they have a fleet of vessels. Say they have 7 sister vessels or 2 sister vessels. In that case, what they do is they go for 3D scanning for one of the vessel, not all 7 or all 2 or whatever it is. So based on that data, they generate, or the drawing and the fabrication is done for all the vessels. But 99 percentage of the time, even if they are sister vessels, you still have some modifications or some changes in all the vessels, which is not accounted. So this is where we see the most of the modifications. Did I answer your question?
Yes, yes. Thank you very much. Sorry, one more question.
Yes, sure.
For the class approval drawings, they usually approve the schematics. 3D assembly and 3D drawings for piping, in many cases, not required to be stamped for approval. So if we have the same diagram, just the modification is not necessarily go to the class again. If I just will
Yes.
adjust the position of the pipe.
Yes, you are right. Most of the cases we don't have to go. As I said, in some cases like the BWTS, in some of the big spools, we try not to modify the big spools. Smaller spools are easier to modify. Bigger spools are not easier. So in that cases, we go for stiffener modification. Any of the main structural members, if or in case we have to modify in the pump room or in the engine room, we still go to the class with those kind of modifications. But still, in that case also, it's not a showstopper. We still can proceed with the works, and class will parallelly work on with the drawings approval or any kind of help that is required from the class.
Okay, thank you very much. Really appreciate your time. Thank you.
Thank you. And now the second topic, what we are looking at is EGCS. Okay, what are EGCS? We know it commonly as scrubbers. Okay, scrubbers or exhaust gas cleaning system are used to remove the particulate matter and harmful components such as SOx, we call SOx and NOx, sulfur oxides and nitrogen oxides from the exhaust gases, which is a byproduct, or I can say a main product after the combustion from the main engines and from the boiler and from the auxiliary generators. So this is in line with those kind of treatment for the exhaust systems. Okay, so I will just go for a quick IMO regulations. From January 2020, the IMO, International Maritime Organization, reduced the maximum allowable sulfur content in the shipping fuel from 3%, 3.5% to 0.5% globally. So which is a very big jump, so to say. Means most of the ship owners or the charterers or the vessel owners had a big issue in the beginning when this was announced, because 3.5% to 0.5% is a drastic change. Okay, and is 0.5% globally and 0.1% in ECA. What is ECA is emission control areas. Okay, these are one of the places where we have the most stringent rules for this kind of SOx and NOx elimination from the exhaust gases. So most of the emission control areas are the Baltic Sea, the North Sea, United States, Canada, and Caribbean Sea. There are few more which is being added, like Australia and some places in China is being added now. Okay, so you can see a graph where you can see that from 2011, this scrubber was in discussion, and slowly the owners started showing interest. Instead of spending too much on the heavy fuel oil with low sulfur, they go for a more cheaper or easier option of installing scrubbers on board. So you can see from by 2020, there was around 4,000 ships which had scrubber installation all over the world, not only in one particular shipyard, it was all over the world. And by 2022, we still have more, but I don't have such data. I will look for it, and in case if I have, I will share it. Okay, so this is the emission control areas that has been that I was talking about. You can see the dark blues. This is where it is mandatory to have 0.5% global limit. Okay, then light blue is also 0.5 percentage in European Union. And then there are some dark blues, which is 0.1%, which is the emission control area, which I was talking about, the Baltic Sea, the Caribbean Sea, US, Canada. And as I was saying, there is few more being added, like China. There are some local ports which has added 0.5 percentage. There is still more places which is in discussion. As I said, Australia is talking about 0.5 percentage as well. Okay, then classification of marine scrubbers. Basically, scrubbers are of two types. Okay, it's either industrial or marine. Some of the industries also use scrubbers, but those are very different from marine scrubbers. So I'm not going into that topic. Those are mostly dry scrubbers. But on the marine scrubbers, you will see this kind of classifications. You will have wet and you will have dry. Again, on the marine scrubbers also, most of the time it is wet scrubbers because those are the most available and the easier one to manage or do the maintenance and the cheaper option. Okay, dry scrubbers usually use the lime granule, and this is a bit hard to do the maintenance and to manage. So most of the owners go for the wet scrubbers. In wet scrubbers, we have three types of loops. We call it closed loop, hybrid scrubbers, and open loops. The most common used by the ships is open loops. And a few vessels will use are using closed loops and hybrids. Hybrid is very rare, where you have option to run it in open loop or in closed loop. So even on the hybrids, you have two categories: scrubbers using only seawater, scrubber with several sea and freshwater running options. Okay, this is the open loop scrubber. Excuse me, give me a moment. Okay, so this is the open loop scrubber system. So where you see that the scrubbing is done by seawater. Seawater is sprinkled in the scrubber to remove the SOx and the NOx content from the exhaust gas. So in this case, new seawater pumps has to be installed. This is a very generic and a basic drawing which I'm showing. For sure, you will have to see in the details where you will have every vessel will have at least 2 or 3 seawater pumps. New intake has to be created on the vessel with a new manifold. Then will be discharge manifold. Then the piping running to the scrubbers. Most of the cases, this piping which is running to the scrubber is just a seawater. So we use the carbon steel. But the return line, you see the return line which is in blue, which is the open loop wash water, is slightly acidic after the treatment. So in that cases, most of the scrubbers are using GRE pipe, and it passes through the water treatment. In open loop system, the water treatment is a very basic system where you inject some chemicals and you reduce the pH value, and very small amount of sludge is generated. In these cases, most of the cases, the scrubber generates only around less than 1 cubic of waste during the entire system, is much less actually. So the sludge generated in open loop is very less compared to the other loops. And in this case, after the water treatment, it is overboard to the sea. Okay, what are the advantages and disadvantages of open loop system? As I said, open loop system is one of the most easiest, most cheapest, and the most fastest option to install. So it has comparatively less moving parts. And as I said, the design is simple to install on board. You have to go for the pumps for suction, the scrubber, and then you have to look for the water treatment. That's all. Okay, apart from defouling and operation checks, the system requires very less maintenance. Okay, the system does not require storage of waste materials. This is what I was saying. The waste generated in open loop is comparatively very less than closed loop or hybrid. Okay, what are the disadvantages for open loop? Cooling of exhaust gas is a problem faced by wet scrubbers. Okay, what I mean by this is when you are sprinkling the water inside the scrubbers, you generate mist because the exhaust is at 450 degrees. So you generate mist. With this mist, you have all kinds of other issues like corrosion. So this is what most of the owners face after the installation of scrubbers over a duration of time, like say 6 months or 1 year. You will start looking at corrosion issues if it is not maintained properly. There are mist separators inside the scrubbers, so if there is no proper maintenance for those kind of mist separators, you will start facing this kind of issue. Not only that, as I said, the return line from the scrubber, the seawater is slightly acidic. So this is also where you see a problem. Maybe you have seen some videos or some news that you have heard of, that the overboard lines, okay, you start having leaks because of this acidic nature of water. The corrosion is starting from that point. Okay, just one more thing I would like to highlight. I mentioned that most of the piping for the return line is GRE. So the GRE you can have only to one extent, up to the shell. But the shell connection cannot be a GRE pipe. So the last section has to be carbon steel with a special kind of coatings. Even after such coatings, we have seen number of cases where the rust will start because of the acidic water. Okay, then the operation of the system depends upon the alkalinity of water available and is not suited in some of the conditions. So this, okay, the water which is taken from the sea, sometimes you will have alkalinity issue also. Okay, since it is an open loop system, there is no kind of chemical injection before the water reaches the scrubber. So this is a very small issue which only few vessel faces in some kind of seas, not everywhere. And since it is an open loop system, you need a large quantity or large volume of seawater is required for effective cleaning. And hence, okay, with this kind of pumping system, you need to have high power generation. So most of the time, your one of the engine is only auxiliary engines, or the DG is only working for this kind of system, which consumes a lot of power. And also one of the major drawback what we see is emission control areas, zones or ports. You have to run the higher costing fuel, HFO, because even after running these scrubbers, most of the times what we have seen is you will not be able to achieve 0.5 percentage. So when you are close to these kind of ports, you have to run your engines on the low sulfur fuels, which is an added cost to the owners. Okay, then the next loop is a closed loop. You can see on the closed loop, the pump is taking suction seawater and it goes to the cooler and it is sent out overboard to the vessel. Okay, and then there is a freshwater circuit in blue color, which is a closed loop from the process tank going to the coolers and going to the scrubber and coming back to the process tank. Okay, so in this case, you have a NaOH unit also where you are adding some chemical dosing. Okay, and after the process tank, you have a treatment system, you have holding tank, you have sludge tank. In these cases, okay, the fresh water, a bit more treatment is being done as compared to the open loop. Open loop is a very simple process where you inject only the chemicals to neutralize it, to reduce the pH from acidic to close to 7, and then it is overboard. But in this case, you have a bit more of water treatment is being done, and you have a holding tank and a sludge tank. Okay, the advantages and disadvantages of closed loop. Okay, on this system also,
Sorry,
since
I believe
yes,
one was having a question.
sure,
Mustafa,
go ahead.
he was raising his hand, so if he still has the question, Mustafa.
Mr. Mustafa, you can go ahead.
Okay, sorry for interrupting. You can carry
No
on.
problem, no problem. Even at the end, you can still ask if you are able to get me this question. I'll still answer for it. Okay, the advantages and disadvantages of a closed loop. Even this one is having a two different, I can say two different circuit. One is a closed loop for the fresh water and the open loop for the seawater. Still, the maintenance cost is comparatively less than the hybrid system. And as I said, it is independent to the operating environment. It doesn't matter whether the seawater is alkaline or it is acidic, because this is not the seawater system which is passing through the scrubber. It is the fresh water which is passing through the scrubber. And the seawater is only used as a cooling agent. Okay, again, the cooling of the exhaust gas is a problem with wet scrubber system. Okay, is the exact same issues we generate mist, and is the exact same issues that owners face with the rust. Okay, the disadvantages, it requires more storage space for the buffer tank and for the holding tank. Okay, as I said, there is a bit more of treatment on the closed loop system before it is sent overboard. So this all additional equipments will be the added space that we need to look for, or the designers need to look for. Okay, and okay, in some cases, the fitting of the system together, especially for dual fuel engines, can be quite complex. In some systems, like on LNG vessels or on some of the new vessels, you have dual fuel engines. So this can be a bit challenging on these dual fuel engines, because there is not much where you can play with dual fuels on the power output. Okay, so this gets a bit complicated on the power output issue, not on any kind of cooling or any kind of seawater requirement or freshwater requirement. It is purely to do with the power requirement for this kind of system. Okay, and this is the hybrid system. As I said, hybrid system is a combination of open loop and the closed loop. If you see the blue line, you have the pump, the suction from the sea, which is going to cooler, and there is a separate white line which is going to the scrubber. So the separate white line indicates the open loop. So you see the separate white line is passing through the scrubber, and then it is going to the water treatment, and then directly going overboard, sorry. Okay, so this acts as the open loop. And then you have the same closed loop where you pass through the cooler and go overboard. And then there is a separate freshwater system or a freshwater loop. So this is just the combination of two. So the owners have both option of running it on a open loop or a closed loop. Okay, the advantages and disadvantages of hybrid system. This is suitable for short and long voyages. Okay, when you go for the long voyages, uh, the most suited one is the closed loop, because closed loop you don't have to worry much about the power consumption and the seawater conditions or the alkaline nature or the acidic nature of water, and you don't have to worry much about taking in fresh water since it is a closed loop. Okay, and ships with hybrid scrubbing can spend more time on emission control zones. So this is exactly what I said in the first system, the open loop. Open loop, you have to consume more of low sulfur fuel, which is expensive. But in these cases, you don't have to go for low sulfur fuel, you can still run on your scrubbers, which is having a much more better efficiency than the closed loop. When you are using sorry, you will have more efficiency than an open loop. So when you are running on a closed loop, your efficiency is better, and in most of the cases, you will achieve 0.5% on a closed loop. The disadvantages for this system or this hybrid system is more structural modifications are needed to employ this system. The more the equipments you need, more piping, more power requirements, and more space for installing all these equipments. Requires larger storage space for chemicals. The system has a high installation time and cost. Okay, this goes without saying. When you are trying to combine two systems, you still have a lot of modifications to be done, which is required for both open loop and for closed loop system, which requires more time and cost. Again, we do the same clash checks before vessel arrival, when the vessel is sailing or when the vessel is in a port. I will show some examples of the clash checks that has been done on one of the vessel, like existing piping on the upper deck clashes with the scrubber house structure. Not only that, the ladders, the staircases, all this has to be removed or modified. So this all checks or 3D checks is done before vessel arrival. Then the new scrubber drain, the red line which you are seeing is a GRE line. So since in most of the cases, if you are aware, the scrubber is installed as a backpack unit. Okay, we will fabricate an additional structure which consists of the scrubber and is installed in the poop deck. So in those cases, you will have this GRE line coming down from the scrubbers to the engine room and to overboard. In those cases, most of the time we see there are a lot of piping clashes. So these piping clashes is already identified, and the required modification is done once the vessel is here. So in these cases also, we try not to modify the big GRE line because GRE line is expensive to modify. So we try to modify the existing lines. Again, there are some more clash checks. New scrubber drain clashing with the existing piping. The auxiliary engine, new exhaust by, excuse me, new exhaust bypass line clashes with the existing piping. Okay, so this is also one challenging area. In most of the EGCS, we have to do quite a lot of piping modification inside the funnel. Okay, because the existing boilers or existing auxiliary engine also has to be connected to the scrubbers. So this is one of the areas where we have most of the modifications. Okay, and also the overboard. Okay, this I would like to talk a bit on this gray structure. This gray structure is the new manifold, overboard manifold, which is also a GRE structure or a GRE pipe. It's just a pipe with few reducers on both ends. So this kind of manifold is created when you have at least 2 or 3 overboards for this amount of seawater. So in most of the cases, you will see that these manifolds or these pipings, GRE piping, will clash with some of the structures. Again, few more clash checks. Okay, that's all from my side. And as I said, this presentation was more about the practical approach than on the theory. I believe that you guys have some theoretical knowledge on these kind of systems or similar systems, which is of course important when you are discussing with the clients or with the superintendents or with the designers. But I'm talking today more on the practical side. So anything or any questions from your end?
Thank you very much for this amazing presentation. You concluded the subject and covered many points. We really appreciate your time and efforts. Um, my colleagues working in outfitting, usually I invade them. They have larger brains than us in structural design. Because there's so many details, small connections, and I really wish you best of luck in your career. Thank you very much.
Thank you, thank you. And even if you, one of the guys or one of your students have any kind of doubt, you can still write to us and we can still reply to you anytime.
Thank you,
Any
Mr.
questions? Yes, yes,
Uh,
doctor.
do you
Thank you,
have
Mr. Saud.
special software using for this combination between 3D scanning and the 3D modeling?
Yes, yes. Most of the 3D scanners will have these softwares. I can share those details also, what kind of softwares they are using and what kind of design softwares they use to merge these two informations, the 3D scan and the final drawings. I can share those details with you as well. Sure.